Today we are going to see about the migration process from MySQL native replication to InnoDB cluster using cloning method, not with the regular method of logical migration or with using physical. So, like here in this webinar, we will see about how to perform the complete migration from master slave like the MySQL native replication to the MySQL InnoDB cluster using cloning. So myself, Praveen, I'm a database consultant in Mydbops. So it's like a little bit detail about myself. Like I'm more interested on the open source database technology. I'm an Oracle certified MySQL DBA. I'm a AWS community builder. Like I have experience in both in on-prem as well as a cloud environment. Like and all type of topologies as well, like PXE or with the cluster of the group replication, normal replication topology, and the load balancer. All the areas I have got expertise. Then I'm an active speaker, tech speaker, as well as the blogger on the database. So moving on to about MyDBO, like we are providing two type of services, like consulting services and managed services. So we will support around the clock 24/7 with our expertise team. So we are having 100 plus members as a team. So we will focus on MySQL, MongoDB, and Postgres. Yeah, before getting into the agenda of this webinar, like it's good to know what are the pain points that we are having on the current native replication topology. What are the blockers that we are having? What are the issues that we are facing? So it's it will be like a single point, like a point of failures, in because it's going to be have a single master. So that master is going to replicate the data to the replica. Replica will be in read only. So it will if the master goes down, then we need to manually promote the replica to become as the master. So it will be like a single point of failure if the master goes down. So then I will like so once the master goes down, we need to promote the replica as the master. So whereas the complexity will be there. Also, we need to make sure that we are promoting the correct replica. Based on the use case, we will have a filtered replication or with a replication lag will be there. So we need to consider all these scenarios when we are promoting the replica to a master. So it will be a complex one, and also like data consistency, like the consistency will be there, but the constraint is the live data. Due to replication lag, the live data won't be present on the slave. Like if there is a heavy rates has been acquired on the master, then the server will be in lag. If the application is trying to fetch the return data on the master, but it is trying to refetch for displaying from the replica, it won't be the live data because there is a replication lag between the source and replica server. So due to that, the live sync won't be there because it's a asynchronous replication. Master won't bother whether the slave has catched the bottom. Then read heavy overflow, like uh, native replication will be like the source and replica setup will be fine for write workflow. Whereas in the read, after writing the data to the master, immediately we can't fetch it in the replica server if it need to be immediate process because the replication will take certain time to reflect the data to replica. So in that situation, the live data fetching will be interrupted. So to overcome all this issue, we can move on to the InnoDB cluster. So in this webinar, we will see native replication versus InnoDB cluster. Then what are the features that we have in InnoDB cluster? What is the advantage over InnoDB cluster? What is the requirement? Like if we need to move from source to replication, like a native replication to the InnoDB cluster, what are the pre-requirements that you need to check and what are the limitations it has, and how safely we can migrate the data from source replica concept to the InnoDB cluster. So all this detailed thing we will get to know from this video. So first we will see the basics about MySQL native replication. Like it is going to be the asynchronous replication, which means the master won't bother about the replica whether it has catched up the data or it is a live sync or not. Master keeps on writing the data and it, like a slave will pull the data to apply. So, but the one more advantage is there is no limitation. Like as per the replica count wise, it's not limited. We need to have only 5 replicas, 6 replicas. It's not like that. We have a number of replicas. So whereas like the IO thread is going to pull the data from the source server and it is going to apply on the replica server using SQL thread. So the intermediate layer, IO thread will pull the data and it will keep it on the relay log. From the relay log, SQL thread will be get pulled and it will apply to the server. So these processes are there whenever there is a bulk writes is happening on the server. Even though the parallel replication can be minimal, if it is a larger data, definitely there will be a replication lag. So this replication lag will affect the life cycle of the data and also the manual failover processing will be if master goes down. And we have architecture flexibility, like we can have master slave setup or the master setup or we can have a chain topology. Like these kinds of architecture flexibility we will have in the native application. So now we need to compare. So what is the major difference between the MySQL replication and the InnoDB cluster? So as a replication method wise, it's going to be the architectural change. Like it can be the master slave or it can be master master or it can be chain replication. So whereas in the InnoDB, we can't customize that. It's going to be the based on the group replication concept. So the setup, like how the server can be configured, means it can be configured by manual configuration only. Like only the master has been ready, we can send the data to replica server to configure the source and replicate. Whereas in the InnoDB platform, the primary server is ready. We can we can easily add the secondary node by full stream. Like it is a completely automated process, so the data transfer and adding to the cluster, everything will be taken care of by InnoDB cluster itself. So whereas the flexibility, the chain replication, those kind of changes, it will be happen by like it can be customized. Whereas in the InnoDB cluster, we can't do like it's less customization. Like we can have a replica set and down, but we can't configure or change the architecture of the cluster. So the data consistency, like as I mentioned, due to lag, the live data we can't be showed that is available on the replica server. Whereas in the InnoDB cluster, it will make sure that the data is live chain because it is working based on the two-phase commit. So it will give you acknowledgement from rest of the nodes that whether the data or has reached the server or not. So that the commit will. So like these kinds of mechanism it will follow to make sure the data is consistent among all these cells. So then failover handling, if master goes down, in native application, we need to manually promote the uh, like a replica server to the master server. Whereas in the InnoDB cluster, if any one of these, like if the primary node goes down, the next secondary will be promoted as the primary. So at that time, the primary server will be indeed available for the accepting the writes. So these will be automated one. The failover will be these are scalability. So scalability in the term of scalability. So read scaling it can be handled like the data live data will be a issue, But if it's not a bother about the live data, means we can handle the read workload. Whereas in the InnoDB cluster, it can will handle the both the read and the write workload, because the read and write will be spread among the servers. It can be equally spread, like if the writes also need to be handled, when means we can have a multi-primary. So where the writes can also occur on all the server, and also reads can be occur on all the server. So like this, the workload can be well handled in the InnoDB cluster. So whereas this one, like how we can access this. So native MySQL tool itself, we can use for configuring the replication topology and all. Whereas in the InnoDB cluster, we need to use MySQL shell utility to manage the cluster. Moving on to detailed about InnoDB cluster. So, as discussed earlier, like it's going to be completely work based on the group replication concept only, like the quorum as well as the two-phase commit. Everything will occur based on the group replication. So, whereas it's automated failover one, even if primary goes down, the secondary will be get promoted. Whereas the promotion, like how it will be get promoted, there are few variables we need to be make sure, like we can decide which node need to be promoted as next. All the customization that we have made the sub block. I have shared the reference link in the upcoming slides. So that possibility is there. Like once the primary goes down, which node need to be get promoted, how that promotion mechanism is working. All the detailed blog that we have published from my videos. So high availability, yeah. Even if the primary node goes down, we are having the rest of the secondary nodes to serve the traffic. So the availability is high in InnoDB cluster. The consistency and durability, since it's working based on the two-phase commit mechanism, the consistent of data is there among the server. Yes, like it's work based on the quorum. Like the majority of nodes will have the I will give the acknowledgement for committing the data among the cluster, but it will make sure that the all the cluster is having the same data. And also it can be used like we can enable the multi-primary mode, whereas the rates will be accepted on all the nodes. But it's standard to recommend, like it's standard to have a single primary node, not as a multi-primary, because there is a chance of deadlock or other locking issue can occur if the same data or same table is trying to get a lock on multiple servers. It can create a conflict. So it's recommend to have a single primary, but the possibility is but we can have a multi-primary. The options are available for that. So there are requirements are there, but I have listed only the important requirements, like only the notable requirements I have added over here. So all the engines should be InnoDB engines, not any of other engines. So this we need to have the only the InnoDB engines on the server, and also all the tables should have the primary. Primary key should be like is a mandatory one in a group application to like on all the tables. So network performance should be well and good, because the acknowledgement need to be happen from all the node to commit the data. So if there is any latency or any breakage in the network, it will consider as a like a faulty server. So the acknowledgement and the node will the partition tolerance will occur, and there is a chance the node will come out of the cluster. So we need to have a good network for cluster. And also performance schema need to be enabled as well. Then limitations. So I have highlighted few notable limitations for the InnoDB cluster. So the serializable, like the isolation level should not be serializable, and the cluster size can be 9 only. Like only the 9 node can be added to can be in the cluster. So on the binlog section should be none up to MySQL version of 8.0.20. Later, like after 8.0.21, it will be the default of section will be C or C32. So multi-primary mode, like as I mentioned, there is a chance of deadlock is acquiring, so it's not a recommend to have a multi-primary, and also for foreign key with cascading constraint. So it is not supported in the multi-primary mode. Now moving to the migration process. Yeah. So how we are going to plan the migration means? So currently we are having the setup from source to replica, whereas we are going to clone the data from source to the primary node. So by that we are going to have one primary. From that primary we will build the entire cluster. So for this, what will be the requirement? Like since the cloning has been introduced on 8.0.17, so we need to have the MySQL version greater than 8.0.17, or it can be this 8.0.7. So, as a cloning limitation, the source and destination should have the same MySQL version. So we need to make sure that the source and the replica server should be in the same version. So enable a clone plugin. Since we are going to do the cloning, we need to enable on the source server and the destination server. Then we need to create the required user for taking a backup and for the restoration. You need to create it on the both donor and the receptor node. Then we need to make sure that clone valid donor list has been had an entry. Like entry of a valid source server, so that I will explain in the upcoming slides, and we can start the clone. So as a very first one, we need to make sure that source server, like the source of the native replication and the primary node of the cluster should have the clone plugin is enabled. And then we need to create the donor node on the source server. So donor node, I have for easy understanding, I have mentioned the name as donor, like since it's going to be send the data. So on the source server, we need to create a user, and on the primary node server, we need to create the user. The corresponding privilege has been mentioned. The backup admin should be given for on the user which is creating on the source server, whereas in the clone admin should be provided on the user which is creating on the primary node server. So once these user creation is done, we need to make an entry in the clone valid donor list. Like we need to mention the IP and the corresponding port. So the IP should be the source server IP from where we are going to stream the data, and the port of that corresponding source server. Then to start the clone, we can use the following command. So we need to use the donor user since the connectivity, we need to execute this command on the primary server, which is going to accept the data. So from that we are trying. So we need to use the donor user, which has been created on the source server and the source server IP. Then corresponding port of source server. Since I have shared as a sample one of 3306, which is the default port of MySQL, and the password which has been used for creation of clone donor. And then once the cloning has been triggered, we can able to see how what are the process has been done so far. Like in the primary node, which is the receptor node where the data is going to be replaced. So first it will drop the data, then it will copy the file corresponding pages, then read the logs. So all these status can be monitored. So for now, to have an overall view, I have added the stage as well as the state, whether it is in progress or completed. So we have the start time and the estimated data columns as well. So based on our needs, we can frame a query accordingly. We can able to monitor the progress using clone progress table, which is available in the performance scheme. So once that cloning is done, so server will do a reboot and make the servers available. So post that we need to configure the replication between the source server and the primary server to have a live sync of data from the source to the destination server. So for this, we can able to get the bin log and position from clone status table in performance scheme. So we can able to see like the bin log file and the bin log position executed GTL. So using this, we can configure the external we can configure the asynchronous replication from the native replication to the primary node of this cluster. So now the data has been migrated from source server to the primary server. Now we are going to see how to build the cluster from this primary server with the rest of the server nodes. The data need to be transferred. So how it can be achieved. So we will see about that. So for building a InnoDB cluster, so basically we need a MySQL shell utility because by using shell only we can maintain the InnoDB cluster. Then we need to have a cluster admin user on all these servers. So using that user only, it's the communication as well as adding the instance, removing the instance is going to happen. Then the required variables need to be set at its correct value. Like the transaction dependency tracking should be right set, and the enforce DTID should be on, and the server ID should be unique among all the nodes of the cluster. So first we will create the cluster admin user. So I have shared a sample create statement and its corresponding grants. So what are the grants need to be provided for the uh, user. So we need to create the cluster admin user in all these servers. Then on the primary cluster, first we will build a cluster because that primary server is like one of the slave for that master slave setup. So we will make that server as a cluster. So for that, we are building a cluster called webinar. So once the cluster is done, this corresponding primary server will be automatically added as the primary for that cluster. Then next step for us to add the nodes to the cluster. So how we can add this? We need to fire a command add instance. So with the cluster admin and the corresponding IP, which server is need to be added as the secondary one. So this command need to be fired on the primary node. So by firing this command, it will add the secondary server to the cluster. So this is the command for it. So once we have triggered, it will ask for like whether it need to be perform using clone mechanism or incremental recovery. Like incremental recovery, we can use when there is an intermediate shutdown and we are adding back. But to have a complete data sync, it's suggested to go with the clone. And also cloning is a faster mechanism when compared to any other scale backup. So our MyDBX has provided their detailed blog on the same. So the reference link will be shared. So we recommend to have a cloning mechanism which will have a faster data syncing. So once I have chosen the cloning mechanism, so it will provide us the progress as well. Like currently file copy is going on, or page copy is going, or it copying period. Look, all the progress will be displayed as. So once that is done, it will show like clone will shut down and restart the server at the target. So all the progress will be displayed and it will be added to the cluster. So as I have mentioned earlier as a key feature of InnoDB cluster, right? So all the processes are automated. We no need to spend time for it. So we need to trigger the command. So it's going to automatically add the instance to the cluster. So once we have added the cluster, we can verify using cluster status. So the newly added instance will be secondary, whereas the already added instance will be primary. So I will show a demo like how to add the instance to the cluster. So I will reshare the screen for the corresponding terminal. Yeah. So the left side section, I will use it as the source server, whereas the right side section will be used as replica server. Like the secondary server, which is going to be added to the cluster, whereas the left side one is going to be the primary cluster. So I have a handy comments for it. Like let me log into the instance. Yeah. So as I mentioned, right? So we need the shell utility to connect to the cluster. So by using the MySQL search command, we can log into the shell utility. Once it has been logged into the shell utility, we need to connect to the corresponding cluster admin, like corresponding session using the cluster admin user which we have created for building the cluster. So it will request for the password. So it will ask we need to save it or not. It's not recommend to save the password. So default is no. I'm proceeding with that one. So once it has been added, it has been already promoted as the primary server. So to get the status, like webinar cluster is already built up, and the corresponding primary server is primary. So if we can see, it is a single primary. It will show there is no fault tolerance. Like in case of any failure, we don't have any of the server current. So it is also highlighted. So I will add the new server. Like I will add this server to this cluster. So for that, we need to run add instance command. So once we have added, it will show that which type of mechanism it need to be used. So clone or what? So I'm using the clone only. Yeah. So as we can see that it is getting started. So parallelly we will monitor here as well. So I have populated the data of 10 GB. So how we can monitor is we can monitor using the clone progress state, right? So we can monitor using that how much data is getting transferred. So it is the complete set of that. So we can only limit fetch the required column. So I will fetch the stage as well as the state. So to have an idea like what are the progress it is what are the process currently it is in progress and which are yet to be started. So only drop data, like it will drop the clone plugin will drop the data and it will recreate it. If needed, we can point the data directory also. So all detailed blog we have like MyDBX has published a detailed blog on how the clone plugin will work and how to perform it as well. So all are attached in the reference link. So we can see right like how many percentage it is getting copied and the progress is getting displayed, so no need to go and check it on the destination server. So everything are automated here. So since the data size is larger, so it will take a little bit of time. So in the meantime I will explain C of the mechanism over here. So if the if a clone has identified that any of the extra GTID is over here, it will automatically recommend to use clone only. Like instead of there is another option called incremental recovery. So which will apply the what are the changes if there is intermediate maintenance, right? At the time, if any of the transaction has been happened in the primary server. Those changes need to be applied, then it will choose for the incremental recovery. Whereas if any the complete data sync need to be happened, or if any anonymous GTID has been detected on the target server, it will automatically recommend to have a clone only. So the GTID conflicts won't occur. It will wipe out the data on the destination server and it will reset. So the data, the data will be consistent as well. So there won't be any conflicts in the future also. So the data copy is the data copy will occur and it will entirely recreate the data at the destination server and it will add back to the cluster. So the file copy currently the file copy percentage is 94. It's almost going to get in. Suppose that the page copy and the log copy won't take time, it will apply it fast. So we can see the page copy is complete and the log copy is also completed. Yeah, so once that cloning is done, it will take care of the restart as well. Restart will be occurred defaultly by clone, so we will get the complete process. The restart is done and it is ready. So how long it has been took and how many all the complete statistics, everything will be given as a handy to the end user. So now the instances added to the cluster, we can check the status of it. Yeah, so the newly added server becomes the secondary server. So like this, the instance can be easily added to the cluster.